Hi, Assalamualaikum. We are from Group 12. We'll be presenting limits and tolerance. So I am FARHANNA and my group members IYAD, JURIANA, SYAMIMI, and HADRI. Next slide will be presenting by SYAMIMI.
Okay, first I will explain about the International Tolerance Grade or IT. So to set up a suitable fit, we need the first one is the magnitude of the shaft tolerance zone and the hole. And then the second one is the fundamental division of the shaft and the hole. Okay, the next one is IT numbers IT numbers classify tolerance group so that the tolerance can have the same relative level of accuracy for a particular IT number but different depending on the basic size. Okay, and then the magnitude of the tolerance zone is the vibration in part size, and international tolerance grade number, or we call it as a IT number, specify the tolerance zone. Okay, so we have the range of the number which is IT0 to IT16. Okay, and then the smaller grade number specify a smaller tolerance zone. Okay, next slide. Okay, so this is the table of the tolerance and its application. So there's a lot of tolerance starting from 1 mm until to 2000 mm. Okay, next. Right. So the whole have the basic number. The H is represent for whole, or we call it as a uh, uh, fundamental deviation, and the 8 at the back one is the IT grade. Okay, so the whole H is uppercase, and the shaft F is the lowercase. Okay, same also. The front is the basic size, and then the F is the fundamental deviation, and the back number is the IT grade, and the F7 or the HX is the tolerance grade. Alright, so there are a set of tolerance and varies according to the size of the basic size, and provide a uniform level of accuracy within the grades. Okay, so next. Okay. Alright, okay. The next one is the metric system of tolerance and fits, ISO. Okay, so this is the table for the basic reference for tolerance and fits. Okay. So that's all from me. So I will pass it to Juliana.
Thank you, Syamimi. So I'll present about the classes of feeds. So there are three classes. So I'll explain about the first classes, which is clearance feeds. So for clearance feeds, there are 5 types of feeds, which is losing running feeds, free running feeds, close running feed, sliding feed, and locational feed. So loose running feed is used for wide commercial tolerance. Precision is not important, and the code for these feeds is H11C11. So the second one is free running feeds. Um, this feed is accuracy is not important, or large term variation, or both condition. So the code for this feed is H9D9. So the third one is explain about running on accurate machines, accurate locations at moderate speeds and general pressure. Accurate location and minimum play are desired. So code for these feeds is H8F7. So for the sliding feeds is for easy move and turn, no free motion, and accurate location. So the code for these feeds is H7G6. So the last one is location of stationary parts. This one is called locational feeds, and the code is H7H6. So next slide, please. So so for um the next two slides is about the table for clearance feeds. So we can see that the table um, the column, there are about 1, 2, 3, 4, 5 column represent the five types of clearance feeds just now. So so we move on to the example. Can next slide please, to the example. So okay, so for example, this is example for clearance feeds. Okay, certification is for free running feeds. For free running clearance feeds, find hole and shaft limits for base size of 12. So this example, we need to identify the hole limit, shaft limit, and feed limit. So we can see from the table, we we search the free running, and then we choose the which column that base size is 12 mm. So we can see that whole limit is 12 to 12.043. Shaft limit is 11.907 to until 11.75, and the feed symbol is 12 H9D9. So this is the example for free running feeds, free running clearance feeds. Okay, I think that's all from me. I'll pass to the IYAD to explain the other two. Thank
Okay,
you.
so for the other class, which is transition feeds, there's two types, which is first location transition, which represented by H7 key 6, and next one is location transition, which is more accurate, that represented by H7 and 6. Transition fix is actually in between the clearance and interference, where the tolerance zone of the hose and shaft overlap. So it may be result at the clearance or interference depending on the actual value of the tolerance. So for the class is interference feed. Interference feed is actually the external dimension, which is shaft, slightly exceeding the internal dimension, which is the hole. So it can be achieved by it can be interfered using many methods such as heating and using push it together and produce friction. So for the interference feed, there are different types, which is location interference, H7, P6. There are slight interference, and the parts are to be assembled and disassembled with accuracy without bore pressure. For example, couplings, brass, collars. Second one is medium drive, H7S6, which is ordinary steel part, shrink fit on light section, tightest fit for cast iron. And for the third one is force fit, which is H7U6, parts to be joined with high stress shrink fit on medium section. Next slide. So this is the table of the transition and interference fit to find the maximum and minimum limit. Next slide. Okay, this is the same. And we proceed to example. So for the example, for basic hole diameter of 40 mm, H7P6 determine the class of the feed, the limits for the hole and shaft. So the solution, the type of limit, it says H7P6, which we can see H7P6 is locational interference feed, and they mention the diameter of the hole is 40 mm. We see, we look at the column of basic size for 40, and at the locational interference, you can see the hole limit is 40 to 40.025, and the shaft limit is 40.026 to 40.042. So that's all.
Okay, thank you, Iyad. So next we continue to the example. A shaft nominal diameter 25 mm is going to be manufactured. IT grade is required to be IT7. Determine the tolerance on the shaft. So the question asks about the tolerance, and the IT required is IT7. So we take a look at the tolerance column at the IT7 column, and also the diameter is 25 mm. Therefore, we take a look at the basic sizes, and we take the value of 18 over 18 up to 50 for the diameter of 25 mm. Okay, then we see the intersection between the row of the basic sizes and the column of the tolerance, and we get the 0.021 millimeter. So that is the tolerance, and tolerance is the size limit, is the maximum and minus the minimum size limit of a certain part. Next slide. Okay. So tolerance also can be calculated using the formula provided by ISO, which is T is equals to K times I. T is the tolerance in millimeter. I is 0.45 cubic root of T plus 0.001 T, and D is the diameter, and the unit tolerance of I is micrometer. So D is the square root of D1 times D2, and D1 and D2 is in millimeter, and K is 10 times 1.6 power of ITN minus IT6. So we take the previous example, which is the diameter is 25 millimeter and IT grade of IT7, and we calculate the tolerance. In I equation, we can insert the value of diameter, which is 25 mm, and then we get the value of I is 1.341 micrometer, and for K, we can insert the value of IT7. K is and then K we get 16. Next, we can calculate the tolerance K times I, and we obtain 21.45 micrometer, and the final answer is 0.0 and equals to 0.021 millimeter, which is same as the level. That's all for me.
Okay, so for the geometric dimensioning and tolerancing, which is GD&T. So this is actually state the maximum allowable variation of a form or its position from the perfect geometry implied on the drawing. And the term geometric actually refers to various forms such as plane, a cylinder, a cone, a square, or a hexagon. Okay, so this is the table or the symbol that we actually on the 3D CAD model. So for the type of tolerance, there are form, profile, orientation, location, and runout. So this is the geometric characteristic, which is for form, there are straightness, flatness, circularity, cylindericity. So this is the symbol for that. And for profile, which is profile of a line, profile of a surface. So this is the symbol for profile. And for the orientation, which is angularity, perpendicularity, parallelism, this is the symbol for the orientation. And the symbol for the location, which is position, concentricity, and symmetry, this one. And runout, circular runout, the arrow is the symbol. Okay, so this one is the symbol and the description. So, okay, so as you can see here. Okay, so next is the diagram. So for the first symbol, this one is a geometric characteristic symbol, and the second symbol is diameter symbol indicating a cylindrical tolerance zone. This one is tolerance. Next to it is material condition modifier, and A is primary datum, D secondary datum, M is data material condition modifier, and the last one is tertiary datum. Okay, so this one is the tolerance and CAD 3D model. So this one is for the SolidWorks software. So this is the symbol that I already presenting previous. So I think that's all for our presentation. Thank you.